Hello students, welcome to the world of chemistry. This is Dr. Vikram Panchal and I'm dealing with chemistry spectroscopy. This is lecture number 35 for UV visible spectra. In this lecture, I will explain you what is exocyclic double bond. In fact, I have started explaining exocyclic double bond in previous lecture, but unfortunately because of time constraint, I could not explain you properly. So I am repeating this exocyclic double bond once again. You know, when carbon-carbon form double bond, or two carbons always involved in formation of double bonds. Okay. So if one of these carbon is a part of a ring, it can be 5-member ring, 4-member ring, 6-member ring, 7-member ring, doesn't matter. But if one of the carbon is part of the ring like this, then it is known as exocyclic double bond. So one carbon should be part of the ring, another carbon should be outside the ring. So it is called exocyclic DB or double bond. Okay. So in fact, there should be this type of structure. It can be here or maybe here. So there are all possibilities for having exocyclic double bond. All these bonds are called exocyclic because one carbon of double bond is part of the ring and another is outside the ring. So all these carbons which remain outside the ring considered to be exocyclic for them. Okay, so that is why this bond is exocyclic double bond. Well, there are various types of possibilities of exocyclic double bond you may come across when you will doing some numericals. For example, this one. There are two rings A and B. Now, if you see A ring, then this red carbon is a part of this ring, but blue carbon is not in the A ring. Therefore, this double bond is exocyclic for A ring. So this becomes exocyclic double bond for A ring. Similarly, when you consider B ring, then blue carbon is in B ring, but red carbon is not the part of B ring. That means the same double bond can be exocyclic for B ring. So this is second time exocyclic double bond. So it is the same double bond, but it is exocyclic for B ring. So similarly, you will find one double bond may be exocyclic for more than one rings. Okay, we take one more example. Suppose there are many rings and not necessarily all rings are 6-member unit. It can be anything. But if we have this type of structure, for example, now here there are 3 rings A, B and C. Okay. Now let us take this one. See, double bond should be the part of system. It is first condition. Second condition that, see, this is the system for us and double bonds are in different rings. So it is heteroannular double diene system, and this is extension of this system. Why? Because this double bond will be in conjugation with the system. So there are total 3 double bonds in the system. Now we'll have to see each one, whether each one is exocyclic double bond for different rings or not. So these are the carbon involved in ring or in system. I will give number C1, C2, C3, C4, C5, C6. Okay. Now the double bond between C1 and C2 is in A ring. So this is endocyclic double bond for A ring. So the double bond between C1, C2 double bond is endocyclic double bond for a ring. Now, will it be exocyclic for any other ring? The same double bond? Yes. Why? Because C2 is in B ring, but C1 is not in B ring. Therefore, C1-C2 double bond is exocyclic double bond for B ring. Why? Because one carbon is a part of B ring, but one carbon is outside the B ring. That's why it is exocyclic for B ring. Now we see the double bond between C3-C4. Now C3-C4 double bond is in B ring because both carbons are in B ring. So it is endocyclic for B ring. But you see that the C3 is in A ring or B ring. Sorry, A ring also. But C4 is not in A ring. And therefore, C3-C4 double bond is exocyclic double bond for A ring as well as for C ring. This way you can see even the double bond between C5 and C6, and you will observe that C5-C6 double bond is exocyclic for B ring and not for C ring. Okay, so for C ring only C3-C4 exocyclic double bond appear. Why? Because C4 is in C ring but C3 is not in C ring. So this way you should know how to calculate or how to find out exocyclic double bonds in calculation of lambda maxima. Please be careful when you are considering exocyclic double bond. Now next stage is substitution. Along with carbon of a system. The first one, which is very important because other functional groups are easy to identify the substitution, but the one most important is alkyl substitution. It is also known as ring residue. So normally we write RR for this. It is ring residue. What is ring residue? So let us take example, then you will understand this. This is diene system, and as there are two alternate double bonds or conjugated double bonds, this is called a heteroannular diene system. Now in this diene system, there are few carbons like 1, this is C1, C2, C3 and C4. Okay, so these are 4 carbon systems. Now we'll have to see that if any other carbon atom out of this 4 is attached to external carbon atom or not. For example, C1 is attached to this carbon, a green carbon, which is not a part of system, but this C1 is attached to this carbon of out of this system, and therefore this is known as alkyl substitution or ring residue. It is called ring residue. Now check C2. Now C2 is attached to C1 and C3. So C1 and C3 are part of ring or the system. Therefore, we will not consider them as ring residue. Remember, a ring residue should be a carbon attached to this carbon of a system, but it should not be the part of the system. Now we take this one C3. Now C3 is attached to this carbon, which is not in the system. So it is also called ring residue. Okay. Next, C4. C4 is attached to this carbon, and this carbon is also not part of the system. So it is also known as ring residue. So this way, you have to find out ring residues. Okay. So if carbon is attached to the carbon of diene system, which is not the part of diene system, then it is known as ring residue or alkyl substitution. And 5 nanometer is added in lambda value or base value for each ring residue. If other functional groups are attached, to the system, then there will be addition of certain value to the base value. For example, for ring residue, we add 5 nanometer. Similarly, if OCOCH3 group is attached to system, then we add 0 nanometer. Then if OR, that is etheric group, R can be methyl, ethyl, with propyl, anything, then we have to add 6 nanometer. If chlorine or bromine are attached to system carbon, then we add 5 nanometer. If disubstituted amine is attached to the system, then we will add 60 nanometer for that. R can be methyl, ethyl, etc. If OH group is attached to the system, then we add 0 nanometer. Remember, all these values will be given to you when you have to calculate lambda maxima for any unknown substance. But you should remember this one. Okay. So these are the basic things you have to remember for calculation of lambda maxima for diene systems. Okay. There are certain things. First, find out this type of system and add base value according to this. Then add 30 nanometer for each extra conjugated double bond. Then add 5 nanometer for each exocyclic double bond. Then add certain values according to the substitution or functional groups attached to this. One more thing, we have to add solvent correction also, because in certain case solvent correction may change the values, but when we are referring diene systems, for solvent correction we add 0. Thank you so much for this lecture.